Okay, this is, I forgot to label this one. This is 5.4, I believe. Yeah, we're in 5.4 here. And it's going to be interpreting what's going on in these equations here, and then write an equation for it. Or in this scenario, write an equation for it. Right, so first thing you got to do is kind of read the general gist of what's going on. And in 2009, that's a value, okay? In 2009, we can say that 2009 equals time 0, okay? He observed 326 manatees at the park, okay? He returned each year, and he found that on average there were 11 fewer manatees, right? So this is 11 manatees per year less, right? So you can kind of like put that in terms of mathematics, right? So I'm gonna make up a little like real quick drawing here. This is gonna be, I'm going down. I start with some number and then it goes down, okay? Because it's a negative slope. And so I started with, well, 326 manatees, okay? And this was in 2009. So that's time 0. Okay, so then I'm gonna be like, all right, well, what's my slope gonna be? Well, my slope is my units for my slope is gonna be the thing that has both units in here, because this is manatees, this is years, right? So you can identify your slope, right, based upon the parameter that you were able to come up with, and your parameter is going to have a manatees per year. It contains manatees per year. Change in y over change in x equals your slope. Okay, so if you look at your units, it's manatees over years, and that equals slope. So my slope here is 11 manatees per year. Okay. So, looks like I have a y-intercept. So I'm going to say that y equals my y-intercept of 326 manatees. Okay, that's what I started at. And I'm going to subtract 11 per year. My year is my x value. Okay, so we're in years. Right, so there's my equation. Right, I can rewrite it as y equals negative 11x plus 326, right? But either way, that is what it is. So in 2015, right, if we projected this continuing this way, or continuing this way, right? So we're going to have fewer manatees in 2015 at the rate it's going, right? So 2015 minus 2009 equals 6 years. Okay, so we're going to plug in 6. Plug in 6 to my function, and it'll say, hey, y equals 326 minus 11 times 6. Right, so in those 11 years, or in those 6 years, right? Let's look at it with unit. This is with unit analysis. 326 manatees minus 11 manatees per year times 6 years. Okay, and you can see that I can't subtract manatees minus manatee years, right? It's going to be manatees, right? So after 66 years, or I'm sorry, after 6 years, 66 manatees are going to be gone from its original population. So y equals 326 minus manatees minus 66 manatees. So 326 minus 66 equals 260 manatees at that rate. Okay, so that's how you kind of you pick apart these things. We have one in 2000. The EPA we're feeding lettuce to them so they can reverse the shrinking trend, so that it will not grow so that it will not grow at the rate of 2. Reverse the trend so that it will now grow. So it's going to grow at a level of 2,000 manatees per year. So now I have a new slope. So my new slope is going to be 2. And I'm like, okay, well, by the year 2021, from 2015, it predicted at the beginning of the year they can reverse the shrinking trend. So, okay. All right. So, let's figure out my new equation here is going to be my y equals, and then whatever I started at. So in 2009 or 2021, let's ask some questions that they asked from this. Let me pause this for a second. There we go. Okay, so it continued. So right here, this rate continued until like 2021. Okay, so in 2021 they started doing this so that it would reverse it. So it continue on this rate in 2021. So the difference between 2021 and or what was it, in 2009 and 2021 is 11 years. So what is our initial population starting at before they started this new manatee recovery thing? Okay, so we started. So we continue with this. It's 326 minus 11, and now it's 11 years because 2021 minus 11 is that, right? So how many were left when I started this program? So 326. Whoops, well, that's minus 121, 326 minus 121. So they finally got this program started with 205 manatees left. Okay, so that's when they started this program. And now it's growing at a rate of 2 per year. So now my equation is y equals, this is now my new starting point, 205, all right, and then it's going to be plus 2 times x, where x is my number of years. All right, again, you can use y equals 205 manatees time plus 2 manatees per year times x number of years, x years. Okay, so now it's like, okay, well, what year at this rate, what year is my population gonna rebound to 326? Right, so I'm solving for years here. Okay, and I know y is now going to be 326 equals or equals positive 2 manatees per year times x years. Okay, and this is manatees. Okay, so now I'm going to have to, and then I started with, don't forget my y-intercept, I started with plus 205. Okay, so I'm going to move this over here, and 326 minus 205 manatees equals lost that 121 manatees, right? There's 121 manatees. I need to recover 121 manatees by some time of year. So how long is it going to take to do that? Well, now I'm just going to divide it by the coefficient of my variable term, which is 2 manatees per year. This is manatees. Okay, and I'm going as x years. All right, so now I have to divide by both sides of this. All right, so now I'm going to divide by 2 manatees per year. And you see that my manatees cross out. And I can now figure out it's going to be 121 divided by 2 per year. It's going to take 60.5 years, 60.5 years to recover that population at that rate. Okay, so that's how you kind of like work through these equations. They're pretty straightforward. Unit analysis works a whole lot if you know how to use it. So if you don't know how to use it, come talk to me. I'll help you.